Have you ever seen a building that can house 8 billion people? You think he's 1.7 million stories, or a super pyramid, or is it a super cube? In fact, a super building that can really live for everyone. The highest may only be 400 meters. I am an old horse. Today, we use engineering thinking. Let's take a look at these 4 options, especially the last one. It will directly subvert your imagination. In fact, this idea originated in Japan. Bubble economy at its craziest. A professor said, stop building cities. Just build a building. Put the whole of Tokyo in it. This is the Hashibetsu Tower in Tokyo. 10,000 meters. Could house 30 million people. It is the highest that has ever been seriously conceived by humans. The craziest building scheme. But that is not the limit of our imagination. Now we're building. Finally, don't forget to give the building a name. Of course, the site must be selected before construction. Find the perfect place to build. It had to be open and flat. The geological structure is not also in mountainous areas. Also avoid earthquake-prone areas. Tokyo Babe Tower itself has this flaw. Tokyo sits right on a geological fault line. Coastal erosion is a problem, so you can't choose a place that is too close to the beach. But you can't live without water, except for survival needs. Daily water must be guaranteed. The average person uses about 100 liters of water a day. 800 billion liters of water are consumed every day. It is equivalent to draining 3 West Lakes. Since you don't choose the beach, then you have to be next to the river. Let's look at a map of the world's rivers. This part of Brazil looks okay. No mountains, no earthquakes, sufficient water resources. The drawback is that it is located deep in the Amazon rainforest. You have to cut down a large forest. Not quite right. And what about along the Mississippi? It is the largest river in North America. Just take a little more than half of the river. There's enough water for everyone in the building. You can also drink from the Great Lakes. We can also lift water from the Gulf of Mexico. It's just that large-scale desalination projects are needed. The area is flat. Geological stability. No need to cut down the rainforest. Mild climate. Summer temperature is suitable. It can also be powered by large-scale solar power plants. Let's put it all together. This is the perfect location. Do you think there is a better place than this? You can tell me in the comment area. Now, there is a place. Next, we designed layman's first plan. And it was the first thing that anybody thought of. Giant cube. Looks the most scientific. The result is the most anti-human design. Calculate the most basic account according to globally recognized livability standards. A person needs at least 30 square meters of living area. 8 billion people down. The pure residential area alone is 240,000 square kilometers. That's an area the size of the mainland of Britain. It's about the same size as our Guangxi province, but it's still just a place to sleep. People need to eat and see a doctor, go to school and work. And there are roads, shopping malls, parks, these public facilities. It requires at least 60% extra space. Add it up. The total construction area reached 384,000 square kilometers. It's bigger than the whole of Japan. It is almost exactly the same as our Yunnan province in China. The fortress is housed in a cube. Just a little bit about computational logic. The floor height of the room is calculated at 3 meters. So this cube building is going to be a little bit about bigger. 10.6 kilometers The height is about the same as that of a civil airliner. Flight altitude. The size is exaggerated to unimaginable. But it just fits everyone in the world. But it has a fatal flaw. Used in giant cubes, most people never see the sun at all. After specific calculation, a full 99.6%. The residents are all in the middle of the building. No windows, no sun. It's no different than living underground. That is to say, only 1 in every 250 people can see the sun. But we must ensure the quality of living. It's unacceptable without sunlight. And the differences between residents are edge dwellers dark inside by windows. It is easy to lead to contradictions, and so the giant cube solution doesn't work. Let's change to another shape. How about a more stable pyramid? After all, this is the shape of the Hashibetsu Tower. It turns out to be worse than the cube. From a structural perspective, pyramids are more stable than tall buildings that go straight up and down. Also calculated by the total space required. Pyramid volume. After the formula is converted, the base of this giant pyramid is 15.3 kilometers long. The altitude is also 15.3 kilometers. It's wider and taller than a cube. But it's still a huge problem. Only 0.34% of households have windows. Only 1 in every 300 people has access to the sun. Not as good as the previous cube. Looking at it now, these two forms also have a common flaw. Unable to scale flexibly. Now build the cube or the pyramid. The global population will continue to grow. If you want to add space, you can only add floors to the outside. Especially the pyramids. Once the outside is covered, residents with windows outside, immediately blocked from lighting. So let's think outside the box. Change to a more reasonable shape. And the goal was to do two things. Larger surface area. Lots of more viewing windows. It expands naturally as the population grows. At this time, we need to learn from nature. Build a giant honeycomb building. Leave a hollow area in the middle of each hexagon. Can dramatically increase the number of households with windows. Size setting. Each hexagonal outer ring has a side length of 100 meters. The inner ring side is 50 meters long. To accommodate the entire population, over 17,000 hexagonal units are required. The total area is approximately 20 kilometers by 23 kilometers. Total building height 3,457 equivalent meters. To 4 Burj Khalifa stacked on top of each other. A honeycomb is shorter than a cube. It has a bigger footprint. Focus on daylighting. The plan has finally improved significantly. 14% of households have windows. 1 in 7 people has a window. Finally see hope. However, there are still shortcomings. Although much shorter than the first two, but 3,457 meters is still sky high. The higher the floor, the more pressure there is on the bottom. The higher the risk of collapse. You know? The Burj Khalifa is currently the tallest building in the world. 828 meters. The last one is the one that can really help Final people. Plan. The designers borrowed directly from the neighborhoods of Barcelona. This town was built in the 19th and 20th centuries. Designed by urban planning genius Zelda. It is a pioneer model for modern urban planning. It's designed as a grid of blocks. There are apartments on and around every household has enough light. The streets are wide. Ventilation and sunlight are very good. Corner cuts around the block. Further, broaden the street view. Improve ventilation and lighting. So let's apply this to super buildings. First, build a 100 meter high giant. The base material is dense and sturdy. Extremely pressure resistant. Avoid total collapse at its root. Above the base, build thousands of high-rise slab residential buildings. Reenacting Zelda's block layout. Transparent on all sides. Erect a sky corridor between the buildings. Easy to pass through each other. Reserved passage under the building. Paving roads and rail transit. We're using the original block scale. Each block is 100 meters long. Streets are 20 meters apart. The original block is only 16 meters high. A residential building is much taller. Conventional building height 300 Section 400 meters. The shorter 200 meters. High and low are more conducive to overall lighting. And a sky park on the roof of a low-rise building. Garden green space. The functional partition is also very clear. High-rise residential buildings are dedicated to living. Office building. Hospital school. The communal facilities are all concentrated in the bottom pedestal. Daily work and school. They just take the elevator in the center of the building. Just go down to the base. You don't have to leave this building for the rest of your life. Measured by scale. On average, about 25,000 people live in each block. 8 billion That's people. 320,000 blocks. The overall side length is nearly 69 kilometers. Although he solved most of the previous problems. But let's be honest, this is almost beyond our imagination. It's like a whole building. It's more like a supercity on a pedestal. City, of course. No matter what structure, it's hard to imagine. The cost is astronomical. It's just a skyscraper. Can cost as much as $1 billion. Let's make a rough estimate of this whole set. The total cost is about $320 trillion. And that's not even manual. The additional cost of resource shortages. If one day in the future, when humans have to live in the same building, construction teams are sent around the world to build together. Do you think humans go all out to fight? Can this kind of super project be built? I am an old horse. See you next time.